Okay, you can see that I've got the assignment from section 9.6 up on the screen, and it's titled Inequalities in Context. So the I can statement here would be I can solve inequalities in context. So notice that the instructions here, there are some differing instructions here, and there are a lot of words here, and not so many numbers as what we've seen in inequalities as we've seen over the last week or so. So as you're looking at this, here's the idea. Follow these instructions, and on some of these you're just going to translate them into an inequality, and then on others you're actually going to have to solve the inequality that you translate. So this one says, I'll zoom in on this here. So this first part says, translate the verbal sentences into an inequality. Do not solve the inequality. Now that's good all the way down until we get to the next set of instructions, which is right here. So basically on 1 through 10, all we have to do is write down the inequality. We don't have to solve it or anything like that. And you'll notice that these are relatively short. So let's take a look at number 1. It says x is at most 50. Now let's stop and think about that, and sometimes it works to think in terms of a number line. X is at most 50. The most it can possibly be is 50. So if we were thinking on a number line, if 50 is right here, the biggest it can possibly be is 50. So 50 is like our cutoff, and then it can't be anything bigger than 50. So this is okay. This is not okay, or in other words, these are answers and these are not answers over here. So our answers would be down here. So x and 50, those would be the things that we're comparing. X has to be on this side. X has to be less than. The answers have to be less than that. But then we have one more question when we're talking about an inequality. Could it actually equal that? X is at most 50. So if we were to say something like the most you can get on the test is 50, could you get a 50? Yeah, you could get a 50. So we're going to have that equal to, and we're going to circle that and we're done. Now remember, these ones say do not solve, so we just write it down and we're finished. A number times negative 6 is no more than 48, is no more than 48. So a number times negative 6, let's think about how we'd write that. Probably going to use an x, so x times negative 6. Let's do negative 6x. And then what we're going to compare that to is we're going to compare that to 48. So whatever this is, a number times 6, this big blob right here, is no more than 48, is no more than 48. So is 40 okay? Is 45 okay? Is 50 okay? Is 60 okay? Is 0 okay? So you could kind of run through and think about, okay, we're coming right up to 48. Okay, so is no more than 48. It can't be more than 48. So that's a different way of saying this same type of situation right here. Is no more than 48 is the same as saying at most 48. So this is going to be a less than or equal to. It can actually equal to that because it says it can't be more, but it could be equal to it. So we're going to go ahead and circle that right there. Okay, let's take a look at number 9. Twice a number increased by 6 is at least 35. Twice a number increased by 6 is at least 35. Let's see. Twice a number, 2 times x, increased by 6. If you increase something, you're going to add. We're going to add 6. And we're going to compare that to 35. Is at least 35. Is at least 35. So it's 35 or more. So it's going to be greater than 35. At least 35, that means it could equal 35. 35 or more would be another way of saying that. Okay, let's go back and take a look at number 8. When x is divided by 3, the quotient is more than 5. When x is divided by 3, so when we take x and divide it by 3, the quotient, or the end result of this division process, is more than 5. So we're comparing it to 5. So that's got to be more than 5. Well, if it's more than 5, it's bigger than 5. Could it equal 5? Not if it says it's got to be more than 5, so that would be the answer right there. Okay, let's take a look at this next part. Now, on these it says write an inequality to represent each situation, then solve the inequality. So we're going to translate from these story problems, from these inequalities in context, and then we're actually going to solve that inequality. So notice what I've got highlighted here. I've got 11, 12, 14, and 15. Let's see if we've got any on the back. Just a couple toward the end there. So let's go back and take a look at these. We've got to translate these into an inequality. So it says on number 11, Kayla has $100 in the bank and deposits $35 each week from her summer job. How long will it be until she has at least $480? So just like when we were doing these as equations in context, let's kind of step through what happens. She's got $100 in the bank, so let's put 100 right here. And then she deposits $35 each week. So she's going to put $35 in each week. So we're going to be adding a certain amount, okay? But she does it every week, and it says how long will it be until she has at least $480? Probably ought to have a question mark on that, shouldn't we? Okay. So what we don't know is how many weeks it's going to take, but she's going to put in $35 each week, so we could have W represent the number of weeks. So like the first week she's going to put in $35. After the second week, we times this by 2, she would have put in $70, and so forth. And we want to compare that to 480. And she wants to have at least $480. Well, at least means whatever she saves has got to be greater than or equal to 480. So there's the inequality that represents the situation. And then some of you might be thinking, hey, we forgot to do something. Let's say W equals the number of weeks. Okay. All right. So let's see. Let's solve this. We're going to subtract 100. So 35W is greater than or equal to 380. Again, I don't change the direction of the inequality there. We're going to divide by 35, and we're going to get W is greater than or equal to. Now, because this is a story problem, we can actually use decimals on this if we want to, if this doesn't work out nicely, which I don't think it does. So 10.85. So 10.85. Okay, now there's the answer to the inequality, but let's make sure we answer the question. And this is why we practiced this stuff when we were doing equations, because that isn't necessarily just the answer sitting right there. So this is the number of weeks. Now she put $100 in the bank, and then every week when she gets paid, she puts $35 in from her summer job. So what this is saying is that the number of weeks it's going to take to get to 480 is 10.85 weeks. Well, she doesn't get paid 85% of the way through the week. So she's going to have to wait. Would we say it's going to take 10 weeks, or would we bump it up to 11 weeks? Well, in this case right here, we're going to have to wait until that 11th week when she gets paid, and then she's going to put that money in, and it'll actually go over 480. But again, here it said that she had to have at least 480. So we're going to say this: it will take 11 weeks. We'd round up in essence here. Okay, let's take a look at the next one. It says Amir had $19 to spend at the carnival for admission and rides. If he paid $5 for admission and rides cost $3 each, what is the maximum number of rides he could go on? Okay, so let's think about this. He's got $19. He's going to pay $5 to get in, and the rides cost $3 each. Okay, what we're comparing this to is how much money he's got in his wallet. And again, don't be tempted to be doing arithmetic in your head and stuff like that. You've got to write down an inequality. That's what we're practicing here. Not necessarily knowing what the answer is, but knowing how to set it up so that when you get to more complicated things down the road, you'll be able to do those. So he's going to pay $5 to get in, and then he's going to pay $3 for every ride. So I'm going to do 3R, and we're going to say R equals a ride. Or we'll say rides. And we've got to compare that to $19. Well, if this is what he's going to spend and this is what he's got in his wallet, stop and think about how these would have to be related. $5 to get in and then $3 a ride. It can't be more than that, so it's got to be less than that. What if he was able to spend exactly $19? Would that be okay? Could it equal 19? It could. He's going to leave there with no money, but that would be okay. So let's go ahead and solve this one. So there's our inequality. That's the answer to this part. Now we want to solve it. So we want to subtract 5, doesn't change the direction. Divide by 3, doesn't change the direction, and we get r is less than or equal to, let's see, that's going to go in there 4 and 2 left over, so 4 2/3, 4.66. We'll just double check here just for comfort's sake. 14 divided by 3, 4.66. Okay, now remember what the r represents. R represents rides. He can go on 4 rides, but can you go on 0.66 of a ride? Can you go on 2/3 of a ride? So the answer to that is no, he can't. So this is the answer to the inequality, but that's not the answer to the question. It says, what is the maximum number of rides he could go on? The maximum number of rides he could go on would be 4. So he can go on 4 rides. Okay, a little bit different than solving an equation in context, because a lot of times the answer that we get here, the number that we get, is the answer to the problem. Not here, because this is a real life situation. Can't go on 2/3 of a ride. She's not going to get paid 85% of the way through that 11th week. We've got to wait till the end of that 11th week in order to get paid. Okay, Mrs. Scott on number 14 spent no more than $120 to buy a jacket and a skirt. If the price of the jacket was $20 more than 3 times the price of the skirt, find the highest possible price of the skirt. And then it's got a hint here for us, and I chose to do this one on purpose. I think this is one of the more difficult ones on the assignment. So it says, hint, if S represents the price of the skirt, what expression would represent the price of the jacket? So here's what happened. She went into the store and she bought a jacket and a skirt. The price of the jacket was $20 more than 3 times the price of the skirt. So she bought a skirt and she bought a jacket. And then it says the jacket was 20 more than 3 times the price of the skirt. So if we write everything in terms of the skirt, it says what expression would represent the price of the jacket? Well, this jacket was 3 times the price of a skirt and then $20 more than that. Remember, we mentioned before that when you use the word than, we always switch the order that they come in. So the skirt plus the equivalent of 3 skirts and $20, okay, that's what she bought. So there's the skirt and there's the jacket, and then she didn't spend more than $120. So that means that total has to be less than or equal to 120. So here's what we're going to do. We're going to say S equals skirt. We're going to change these, and we're going to say, if you wanted to circle all of that, I guess that would be okay. That'd be fine. Okay, and then we're going to solve this. Remember, this is an S. So this is going to be 4S plus 20 less than or equal to 120. Subtract 20. 4S less than or equal to 100. Divide by 4. We didn't have to switch the direction at all. So S is less than or equal to 25. Find the highest possible price of the skirt. The skirt has to be less than or equal to 25. So what's the highest possible price of the skirt? On this one, we can say that that number right there is the answer, because it would be in dollars or cents, and this one happens to be just a whole number answer, just $25. So the highest price of the skirt, if she's going to keep her total underneath $120, the most she could pay for the skirt would be $25, because if it was $25, let's see, that would be 25, and then plus 3 times 25 would be 75, plus 20 would be 95. So if you add those together, that would be 120 exactly. So the most she could spend for that skirt would be $25, because the jacket was quite a bit more expensive. There's the skirt and there's the jacket. Okay. All right. Number 15, Jenna has $10 and needs to take a taxi as far as she can. If the taxi charges $1.75 for a flag drop fee and 65 cents per mile, how many full miles can she go? So we're interested in full miles here. So let's take a look. Jenna has $10 in her pocket. So this is similar to kind of like going on a ride at the amusement park or at the carnival here. So a flag drop fee, if you haven't ridden a taxi before, when you get in the taxi, they push a button and they charge you a certain amount right up front. You can get in and say, hey, go here. You can drive 2 feet and say, oh, I changed my mind. You're still going to owe them that flag drop fee. So you're going to pay $1.75 to begin with, plus 65 cents per mile. So we're going to do 0.65 times m. And of course, m here is going to be the number of miles. And then she's only got $10, so she can't spend more than that. So the total bill that the taxi driver gives her has got to be less than or equal to $10. So there's the inequality that represents the situation. We're going to go ahead and solve that. Notice that this has decimals, so I'm going to subtract $1.75, 0.65m. Subtracting doesn't change the inequality. Of course, if you subtract $1.75, that's going to give us $8.25. And again, if you just want to double check, it's always a good idea, especially on a test. Just make sure you don't make any silly mistakes here. So we've got 825 for the mileage distance here, so let's divide by 0.65. Again, you'll notice that we haven't really switched any directions of inequalities on this page, so that's going to happen pretty typically. So we're going to do that answer, and we're going to divide by 0.65, and we end up with 12.69. So this is, m, 12.69. Now remember, m represents miles. So the number of miles has to be less than 12.69 miles. So if we were interested in spending all the money, we could go 12.69 miles. But this question is, how many full miles can she go? So she certainly can't go 13 miles because she doesn't have enough, but she can go 12 miles. So we can just write 12 miles. There's the answer to the question. Okay, got a whole bunch going on here that you can run through and think about. You'll notice then when you get to 20 and 22 and some of these other ones down here, it actually has some multiple choice questions, so you can just choose the best answer from what was given to you. And let's take a look at number 23. So a cellular company advertises a cut rates phone service for $9 a month plus 45 cents per call. If your budget allows you to spend at most $15, what is the maximum number of calls you can make? Boy, that would be expensive. 45 cents a pop. Well, let's see. They're going to charge $9 a month just to have your phone, and then they're going to charge you 45 cents per call. So I'm going to do a C for call. So let's do C equals a call. And then our budget is $15 a month. So we would be okay spending that $15, equaling $15, but we can't go over, so we've got to be less. So there's our inequality. And then we'll just solve that inequality like we did before. So we're going to subtract 9. So that means we've got 0.45c less than or equal to, this would be 6. So we're going to divide by 0.45, divide by 0.45. So we get c less than or equal to, and let's see what we get here. 6 divided by 0.45. My gosh, those are expensive. We get 13.3 repeated. So it says, what's the most number of calls that you can make? So you certainly can't make a third of a phone call, 0.33 repeated of a phone call. So the most would be 13 calls. Okay. Now, I've got this last problem here for a reason. This is actually a great problem to do, because you're going to run into things like this. You might ask yourself this very question. So it says, Ty receives quiz grades of 80, 86, 73, and 91. What grade would he need to make on the 5th quiz in order to get a B average? So in other words, at least an 80%. So at least 80%. So let's stop and think about this. He's going to take 5 quizzes, and he wants a B average, an 80% average. So stop and think about how we average 5 things. Well, to average 5 things, you're going to add them up and you're going to divide by 5. So that would be 80 plus 86 plus 73 plus 91. That's the first 4, and then we don't know what he's going to get on his next quiz. In fact, let's do this. Let's do Q for quiz. Okay, so Q equals quiz. In fact, that's his 5th quiz. Okay, so we're going to add all those up and we're going to divide by 5. And he wants to get at least a B average, so he wants to get at least an 80. So the average needs to be greater than or equal to 80. So there's the inequality. Whoops. There's the inequality that we'd want to solve. Now, that's what it looks like when it's set up, but let's go ahead and let's simplify this just a little bit. Let's put those numbers together and let's figure out how many points he's got so far. So we've got 80 plus 86 plus 73 plus 91. So it looks like he did pretty well on most of those quizzes. So we get 330. So this is 330 plus Q over 5 has to be greater than or equal to 80. Let's go ahead and solve this. So we're going to multiply by 5. So we get 330 plus Q has to be greater than or equal to, well, let's see, this should kind of make sense because this is 400. If you average 80 on 5 quizzes, that means you had to get 400 points altogether. So if we subtract that 330 that he's already got, let's see, we get 70. Greater than or equal to 70. So what grade would he need to get on his 5th quiz in order to get at least an 80% average? So we're going to say at least a 70%. At least a 70% would do it. Now this next one, let's say Ty thinks, hey, I'm pretty close. Gosh, if all I need is a 70 to get a B, could I get an A? Could I get a 90% average? Well, stop and think about what we'd have to change here. He's still going to take the 5 quizzes. We're still going to find an average. So this side would still look the same. So what's the only thing that's going to have to change here? Well, if he wants an A, we've got to raise his average. It's got to go from 80 to 90. So I'm going to take this one right here. I'm going to take the 330 plus that 5th quiz score divided by 5 has got to be greater than or equal to 90. And you'll notice what this does is 330 plus Q greater than or equal to, instead of having to only get 400 points on those 5 quizzes, he's actually got to get 450 points on those 5 quizzes. So if we do the subtract 330, quiz greater than or equal to, do the subtraction, we end up with 120. Now stop and think about what that means. That Q is his quiz score. He's got to get 120% on that last quiz score. Okay, so we're going to say nope, it is not possible. So nope, can't get an A. And then maybe we'd put something like this. Would need extra credit. That's what it would take in order to do that. Okay. Those are the type of problems that you're going to be doing. They can take a little bit of time, especially when you've got to kind of dissect them and then talk about them and solve them, maybe a couple different parts. But I think this is the only one that has 2 parts. So good luck with the assignment. Pretty well done with the unit, and ready to take some tests.